We are here. All right, so to prevent SQL injection, probably more productive than doing it. The simplest thing is block apostrophes. This is a lot better than doing nothing because it'll stop a lot of those automated tools. It'll stop the most common type, but of course, it won't stop injection into numerical fields. And if you choose not to block apostrophes, but double apostrophes, which is what you're supposed to do to retain them, then you're going to have to be concerned about second order SQL injection, where the fields that contain apostrophes are reused by other parts of your database. Stored procedures are something people recommend, but they really don't address this question. A stored procedure, you define a procedure called register user that takes parameters Joe and secret, and then it does it here, but the point is you can put in master, you can put in this password, foo apostrophe, and it will still work because all that stored procedure does is build a string which is still parsed, and that's the fundamental error. You build a command where it is then parsed by the SQL server to try to match these apostrophes, and that's where everything goes to hell on you. So the fact that it's a stored procedure does not prevent that parsing step, which is the origin of the vulnerability. What fixes it, of course, like I said before, is the parameterized queries. This is where you define the structure and you have a placeholder, just a question mark where the data goes, and that's a data structure that is stuck in there and it is not parsed after you inject the data. So it looks like this. You define the query structure, select something from employee where ename equals here, then you take the user supplied name and then you execute the query. This was the old-fashioned vulnerable code, where you're just going to make a statement here where you add the query text in. And the query text, this is then a single line which has to be parsed at the other end, so it's going to be trying to match apostrophes and so on in that text that came from the user. The right way to do it is here. You define the structure with a question mark there. That is the only line that has to be parsed. And then down here you add user input to variable number 1, and then you execute the query on that. So the data that came from the user is stuck in where the question mark is, but it is not parsed. So if you can have any kind of punctuation that marks it that it wants, it will not be confused. Yeah?
This is for PHP, but if we were using Ruby on Rails or Express.js, Node.js, would we have to do something similar?
Yes, there are versions for every language, yeah. And
so they're not automatically doing this for us in those nice frameworks?
No, as far as I know, nobody is. They really should be. The framework should just do it this way for you automatically. That would obviously fix the problem. Somehow, in 15 years, this is not caught on. God knows why. If you made a framework that did it for them, I would think you could charge more money for it and advertise and get popular, saying our framework will make all queries parameterized. Maybe that's harder to do than I think.
Yeah, I thought that getting popular as a framework, they had to do things intelligently and
well, like I say, but if you ask anyone in the programming department and most developers, they don't think about security at all. They think it's another department for some other team to do later. It's very strange. Anyway, so here's things that can go wrong. You have to use the parameterized queries for every query. If you just pick some queries that look dangerous, like the ones that appear to use data from the user, and you don't bother to parameterize the others, then you're likely to get hosed, because often the user can control something you don't think they can control, and often somebody modifies your code later to add more features, and suddenly something becomes controllable. So you'll often be sorry if you do it this way. Every item of data should be parameterized. If you're going to let the user bring in data that's supposed to choose a table or column name, you shouldn't let them, you should sanitize it with just a whitelist of correct column names. Nothing's allowed except this. Like they really should be choosing from like a drop-down list, effectively, instead of typing in a parameter that can contain funny characters. There are things you cannot parameterize, like the sort by ascending and descending. So if those things have to be adjusted by the user, then use whitelisting again so that they cannot inject arbitrary characters. They can just choose from a list of known good choices. And defense in depth, we mentioned before, this is always a good plan. Don't run all your queries as administrator. If you don't need to have administrative privileges, run as a lower privilege. Then if there is a vulnerability, the attacker will be limited in how much harm they can do. Putting on vendor patches is good to patch known vulnerabilities. And as I imagine you know, you can pay for services. Like if you get Canvas and other things, you can pay for services that will warn you about 0 days. They will warn you about things that have not been patched yet. Their research team is staying on top of it. They will send you bulletins and tell you what the workarounds are for things that can't be patched. Add this to your intrusion detection system or something to block it in the meantime. And that would make you safer if you're worried about sophisticated attackers using brand new things. And then there's NoSQL. Now the thing about SQL is you have these rigid tables. Before you do anything, you have to define the table. The table has to have a fixed number of columns. Every column has to have a fixed data type. This is varchar, this is string, this is text, this is a date, and every record has to be exactly the same. And that makes it easy to search and find things, but a whole lot of the world is not that way, like the web. You got web pages, they don't have a defined, some have images, some have scripts, they have all this junk. So NoSQL is supposed to handle this unstructured data where you just have keys and values, and the value can be anything. So it's a much bigger job to search through it, but everyone's been pushing this real hard. I think Facebook switched to it a while ago, and people thought it would be much better for a lot of real world big data type problems. So you can look up things by key or value, you can use XPath, you can use JavaScript, you can use other techniques to query this thing. So here's Mongo. MongoDB is really a hit. One of our visiting speakers said that if you can even spell MongoDB, people will hire you. So we ought to have a MongoDB class.
Wow.
But Mongo is hot.
Yeah.
And another thing about Mongo is it's unbelievably, fantastically insecure. One of the big hacks last week came. Mongo even tells you in the documentation, don't connect it to the internet at all. So Unicorn, that was out there for about a year, one of those unauthorized illegal phone scanners, would find Mongo databases for you, just thousands of them. And they tell you don't even connect it to the internet, you've got to be out of your mind. Apparently, even if you do change the default password, which people don't seem to do much, it's still vulnerable like crazy if you connect it to the internet, but people do. Anyway, people love it. So this is login code in Mongo. You make a new Mongo, you have define a JavaScript function. This thing called JS is a JavaScript function that's going to do login. So it's going to look for if the username equals the username for the user and the password equals the password for the user, then it will return true. And down here, the object is this executes that JS script, and therefore something is either true or false, so you're logged in or you're not logged in. So it amounts to about the same thing. And of course, now you can inject. If you put in Marcus apostrophe dash dash, that will turn into this if username equals Marcus and nothing else. Now I would think there'd be a problem with this brace, but anyway, apparently not.
Nope.
He says, it doesn't mind the missing brace? Yeah.
That's not, it's so easy to work with it, like you don't, in SQL, like you have those syntax errors all the time. MongoDB will just figure it out and give you some information.
Oh my God, that sounds terrible. That's another way to be vulnerable like hell is when it guesses what it thinks you probably meant, like PHP does. Yeah.
It's really good for hash injection attacks.
What's that?
Hash injection attacks.
Hash injection.
Yeah, I was actually just at work
Oh.
on how to prevent this.
Neat. Yeah, anyway, so you can inject now. Here's another injection. You log in with this username and any password. And what goes on here is the AND takes priority over the OR. So this is A, or 1 equals 1, or A equals A. And it will parse it like this. Because the AND is over there, it will take A equals A and password, which is probably going to be false, and it will take this, username equals A, or 1 equals 1, and that's always true. So even if the password is wrong, the condition is true, and you get logged in. All right, and here's XPath. So XPath is if your data is stored in XML format, and that's what XML format looks like. So if you want to have a name and password thing, you've got an address book, address, first name, surname, password, email, and so on. So here's some 3 data entries in XML format. And the way you query that is with XPath, and you just sort of define these paths here. So this will retrieve all the email addresses, address, email, text, sort of like digging through a folder tree-structured directory to find the data you're looking into. And if you want all the information about the person named Dawes, you put it this way, address, surname, text equals Dawes. And you can see what's coming. This is under the user's control. So again, I can put in special characters. And so this will give me a stored credit card number from that person. So I got address, surname, text equals Dawes, and password equals secret, then give me the credit card number. So here's the injection, apostrophe or A equals A, the old familiar one. And now you get all the credit cards for everybody because surname, text equals Dawes, and password, text equal A or A. And then it goes there. So this condition is always true. It's not terribly obvious to me that this will, oh, I see. The name is Dawes and the password is correct or A equals A. So this is always true for every name and you don't need the password, so you get the whole credit card database. That amounts to about the same thing as SQL injection.
You can actually do it even easier than that, where you can like set a search with parameters and you just search for credit cards and you get the whole.
Great. And yet people love it, and they'll pay money for it. I mean, there must be something wonderful about it to make up for this. Any idea what it is? What's so great about it?
I'm getting paid to do it right now.
Is it faster or cheaper or something?
It's scalability,
Okay.
less difficult to access and so.
So you have to secure it.
Yeah, let's hope so.
Yeah, so here's, if you want to find them, you try putting in apostrophes, it'll break the syntax, and here's the usual stuff that will preserve the syntax and do something very much like SQL injection. So if you want to prevent it, you've got to remove a whole lot of characters and filter inputs with a whitelist. Apparently, there is no such thing as parameterized queries or anything.
Nope.
All you can do is try to filter the data. Oh, that's great, which means you can probably just sneak it through. Yeah, well, that's the way it is. Then there's LDAP. LDAP is Microsoft Active Directory uses it. This stores names and phone numbers. This is what moves directory information around on Windows domains. And the way it works is you match a username this way. If you want to match any one of these conditions, you just put them one after another. So one search term, another search term, another search term. If you wanted to do all the conditions, you put an ampersand at the start, and that requires all these conditions to be true. So this actually makes it safer, because when you're going to exploit it, you'll be able to put something in here like for the username, but you can't get to this. So you can't make a construction like or 1 equals 1, because this is out of your control, the and or the or. So actually you can only do pretty limited things. You can't put in it or, so you can't do the usual one. The directory attributes are hard-coded, so you cannot reach out for anything other than what was going to, the type of data that wasn't going to come out. And it almost never returns error messages. So almost everything is blind. So it can be injected, but in practice it's much less vulnerable. All right, I got a few more eye clickers. Make this thing smaller. What's the best defense? I guess I'll quit at 25. All right, parameterized queries are the essentially perfect defense. All right, which one of these is immune to rejection? Quit at 25. Oh, none of them, which is not one of your options. I can't really grade this one, can I? But the point is, none of them are immune to injection. I should have meant to write this question less stupidly. But there's no right answer for that one. We'll just carry on. Which one is the least vulnerable? I thought I was so clever with that question, but there's a minor defect when there's no right answer available. I'll quit at 25. All right, and that's LDAP, of course. LDAP has a structure that makes it hard to get any benefit from the injection. All right, so I'm going to stop the recording and see who got the most right. Let's make this 129S, chapter 9D. All right.